Welcome, my dear students. In today's lecture, I will explain you about polygon clipping algorithm. So first, understand the concept of a polygon. Basically, a polygon is a collection of vertices, and these boundaries are closed. So it is a bounded region. Okay, so it will be provided with certain vertices v1 to v2 and v3, and all lines are joined together. So it should be a closed object. When it will be a closed object, it allows us to fill it with certain texture or an image, or you can fill it with a solid color. If these lines will be disconnected somewhere, like okay, so it will not be a bounded region, and we cannot fill the solid color or any kind of texture within it, so it cannot be shaded. So first point says in polygon clipping is that a polygon boundary process with a line clipping displays a series of unconnected lines. So as we have gone through, we have finished with the line clipping algorithm. For example, if it is given with, let's say this is the polygon that has to be clipped. So when we will clip this using line clipping algorithm, we will take an input of one line after another. So v1 and v2 will be a one line, v2 to v3 will be a another line, and v1 to v3 will be another line. So each and every line will be treated separately in line clipping algorithm. So resultant will be something like this. Okay, so these lines are not connected together, so these line segments are unconnected. So it has given the result as a series of unconnected line segments. So when it is unconnected, so it will not be the bounded region, so it cannot be filled. So we require in a polygon that all the vertices must be there, and these must be safe. So now it will behave as a bounded region, and it will be a polygon. So our purpose with the help of a line clipping algorithm is now solved with the closed objects. So output of a polygon clipper should be a sequence of, when we get the resultant of the polygon, it must be a sequence of vertices that defines the clipped polygon boundary. So जो polygon की boundaries को define करे, वो series of vertices हमें चाहिए होंगी. So in this we require this as a resultant. Okay, so this will be the series of sequence of vertices that defines the clipped polygon boundaries. So it is performed by processing boundary of polygon against each window, corner or edge. So we have applied, for example, if we have applied a polygon clipping algorithm, so it will be performed across all edges of the window. Okay, so it should go through certain to each and every edge. That is, let's say it is, we can consider it as a left edge, top edge, okay, right edge, okay, and bottom edge. So the clipping algorithm must see each and every edge with respect to its polygon. So clipping has to take place across all edges, whether the polygon is cutting down any edge or not. So once it is clipped against one of the edge, then the resultant is passed to the next edge. So we will see what does it mean. First of all, entire polygon is clipped against one edge, then resulting polygon is considered, then the polygon is considered against the second edge, so on for all four edges. So a polygon has to be clipped against all four edges of the window. So that is the limitation also of a polygon clipping algorithm, that it has to go through each and every edge to clip a polygon if it is required or not. Okay, so very basic. It was given by Sutherland Hodgman algorithm. Because it is divide and conquer, we have to divide the vertices across the intersection edges of the window. So that is the divide and conquer strategy, and it was given by Sutherland Hodgman. That is why it is also referred as Sutherland Hodgman polygon clipping algorithm. Okay, so we are covering it up. Polygons can be clipped against each edge of the window one at a time. Edge intersections, if any, are easy to find since the x or y coordinates are already known. So you have already done that. So whenever a line is passing by, so this intersection can be calculated because you are known with the points x and y, x2 and y2. So you are known with the endpoints of a line, so you can easily calculate the intersection across any edge of the window. So vertices which are kept clipping against one window edge are saved for clipping against the remaining edges. So whatever you have applied across one of the edge, for example, let's say you have this figure. Okay, so for example, you have clipped across this edge. This part will be removed. Okay, you will be having this somewhere. Okay, let's say this. Now you are left with this figure. Okay, so this if we want to clip against the top edge, so this resultant figure will be passed on to the top edge to clip against the top edge. So this will be the after clipping, you will get this. Okay, so this resultant will be passed to the next edge. So in this manner we are passing the result, and edges are saved. V1 V2 edges are saved, and the resultant is passed to the next clipper that is going to clip the vertices against those edges. So the one more point, note that the number of vertices usually changes and will often increase. So here you were having only v1, v2, v3, v4, let's say. So four vertices were there. Now once it is done, so you are v1, v2, v3, v4, v5. Now once it is clipped here, so v1, v2, v3, v4, v5, v6. So the number of edges are increasing. When we are normally it increase, sometimes it also reduce as well. Okay, so let's understand with the help of an example what I am trying to make you understand. So if you are following a step-by-step procedure to clip a polygon, so polygon is given to you this, and this polygon has to be clipped with respect to this window. Okay, so first, for example, it is applied with the right clip. Okay, so right clipping is applied, so this will be treated right clipping. An imaginary line is drawn across the right edge. So whatever is residing from here, you can see whatever is residing on the left hand side of this imaginary line will be considered as the inside to that edge, and whatever is residing here will be treated as outside of that edge. So whatever is residing on the right hand side of this edge will be treated as outside. Whatever is residing on the left hand side of this edge, that will be treated as inside, whether it is crossing the boundary of the window. Okay, so this will also be treated as inside right now. Okay, so when we have taken this edge across which we have to clip. So whatever the area that is coming out of this edge will be removed, and you can see here when the right clip boundary is applied, so this is clipped and you are left with this. So this is the result of the right clip boundary. Okay, so this result will be passed, to the next clip boundary. So here we have taken, let's say, bottom. So the bottom line is drawn. Now when I will draw a bottom line here, so what does it mean? Now on this resultant, so whatever is bottom to it, that will be outside. Okay, and whatever it is above to this bottom, that will be treated as inside. So complete figure, that complete data that is residing above to this line will be treated as the inside content, and it will be outside. So whatever is lying outside this will be clipped, and here you can see, so this is at the bottom. So this complete area has been complete points have been clipped. Okay, and now you are left with this resultant. Now this resultant will be passed to the next clipper, that is left clip, let's say. So the left boundary has been created here. Okay, no, there is no more the bottom boundary, you have the left edge. So you will check out on the left hand side, you will find all the things that lies outside, and here you will find all the things inside. So whatever vertices that are residing outside will be clipped, and you are left with the resultant polygon. Okay, once the left clip boundary is performed, the resultant figure will be passed onto the top clip boundary. So now the resultant figure is this. Now here I can draw the top clip boundary. Now you are no more with the left clip boundary, you are left with the top clip boundary. Now what is lying on the top of this left your top clip boundary will be clipped, or it will not, it will be discarded, and what is coming down to it, that will be treated as inside. So all the vertices that are residing below to this top line will be considered. Okay, will be considered as inside, and rest of the elements or the vertices that are lying above to this top line will be considered outside the edge. So it will be clipped. Okay, so this is the resultant polygon. This is the resultant polygon that you have got after clipping across each edge, starting from the right clip, then bottom, then left, then top. So any order can be stick to it, so you can follow any order, but you have to clip the polygon across all edges. So that you have to keep in mind. So, and the resultant of one clipper is passed to the to the another clipper, that becomes input for the next clipper. Okay, so this is the input for the bottom boundary, and this, once it is clipped, so this will be the input for the left clip. This is the resultant. Now this resultant, after clipping the left clip, this will become the input for the top clip boundary. Okay, so I hope you are able to understand how we are stepping up in clipping a polygon. Okay, so this is simply a statement that we have number of vertices that varies from n vertices v1 to vn, and we are moving from we are considering the polygon edge, that is v1 to vertex v1 vi plus 1. It means that we have here vertex v1, then we are moving towards v2, then we are moving towards v3, vi plus 1 we are going. Okay, and whenever we run the algorithm, these vertices are stored. Okay, so resultant of the vertices are stored while performing polygon clipping algorithm. So this is important to understand, because these are the basic rules through which you are going to clip the polygon. So these are called the Sutherland Hodgman Polygon clipping rules. Okay, so input each edge vertex pair successively. So you have to give the input of each vertex, that is v1 vertex pair v1 and v2, and output is a new list of vertices whenever we will perform a clipping across any edge. So the new list of vertices will be produced. Okay, so each edge goes through 4 clippers. So each edge v1 or v2, any edge is going to pass through 4 clippers, that is left, top, bottom, right. Each and every edge is going to check out where this particular vertices are aligned. So what are the rules that you have to follow to perform the clipping using Sutherland Hodgman polygon clipping algorithm? First point says, let's draw over here. Okay, for example, this is an edge across which you have to clip. Okay, so if first input vertex is outside, if first vertex, that is, let's say v1, okay, v1 is outside and second vertex is inside, that is v2, this is inside. So this is the boundary across which we have to clip. So whatever is lying on the left hand side of this boundary will be treated as, because this is the window. Okay, so whatever is lying on the left hand side of this line will be treated as outside. Okay, whatever is lying on the right hand side, whatever is lying on the right, you can extend this imaginary line up to any limit. So whatever is lying, that is within this window size or that is going outside the window size. If I am drawing any line over here, let's say this, okay, so this will also be treated as outside and this will be treated as inside in this case also. Okay, because this is the edge across which we are going to do the clipping. Okay, so v1, okay, so it is outside, out, and it is in. So v1 to v2 we are moving, that is v1 is out and v2 is inside the clipping area. Okay, so what we are going to do, output the intersection and second vertex, output the intersection and the second vertex means when we will do, when we are moving from v1 to v2, so we have to save the intersection. That will be a new vertex will be created, that is called v1 dash, and the inside point, that is v1 2. So this line will be complete, will be saved. This is the first rule. Okay, and this will be clipped. Okay, fine. So first rule says, if first input vertex is outside, v1 is outside this edge and second is inside this edge, then the resultant will be the output of the intersection. Okay, we are not going to calculate the output of the intersection right now, so simply we are saying that the output of intersection is v1 dash. Okay, we know how the intersection points are calculated. So v1 dash, the new point is, we are calling it as a v1 dash. Okay, and this next point that is residing inside will be saved. So when we are moving from outside to inside, v1 to v2, so this is the resultant, that is intersection point and the inner point. Okay, now if first both input vertices are inside, then just the second vertex, let's say this is the edge, so this is in, I have told you this is outside, this is inside. If the first both input vertices are inside, let's say this is v1 and v2, two vertices both are inside, and we are moving from v1 to v2, so what will be saved, second vertex will be saved, that is v2. What will be saved, resultant will be, when we are both are inside, when we are moving from one vertex to another vertex, second vertex will be saved, that is v1 to v2 will be saved. Okay, now the third rule, I'm finished with the first rule. Second rule I finished. Now if first input vertex is inside, that is the another case, this is in, this is out with respect to this edge. Okay, when you are moving inside to out, so v1 is here and v2 is out. Okay, V1 is here and V2 is out. So output is the intersection only. Okay, you are going to save only the intersection, that is V1 dash. So I'm trying to say that we are moving from V1 to V2 and resultant is V1 dash. Okay, so when we are moving outside to inside intersection as well as the inner point is also saved. Okay, and when we are moving inside to outside, then only the intersection point is saved. Okay, and the last one, if both vertices are outside, output is nothing. So this is the case, that is if it is in, if it is out. Okay, and both vertices are lying outside, let's say this is V1 and this is V2. Okay, when this is the case, so we are moving from V1 to V2 and both are lying outside the intersection edge, then no vertex is saved, none. Means complete line has to be removed, flipped. Nothing is saved in that case. Fine. So these are the basic rules that you have to follow to clip the polygon. Let's see the rules graphically. Now I hope you will be able to understand by looking at this figure that simply you have the outside region, you have the inside region. This is the boundary across which the clipping has to take place. Then when we are moving outside to inside, that is V1 to V2 we are moving. So the resultant will be this V1 and V dash. Both the vertices will be saved. Okay. So this is the case when the second rule says inside to inside. Let's say when both the vertices are inside, then second vertex is saved. When we are moving from inside to outside, okay, so V1, so vertex is the intersection only saved, that is V1 dash is saved over here. So you can see the output. Okay, when we have the vertices V1 and V2 and both vertices are outside, so nothing is saved. Okay, so these are the basic rules that we have to apply to clip a polygon. So let's apply these rules to clip a polygon on certain problem. Don't panic with this figure because it is quite easy to understand. Okay, we have followed a fixed order, that is in every question we will be following this order, that is we will first choose the left clipping, then we will go for the top clipping, then we will go for right, then we will follow up to the bottom. So we will call it as a left clipper, top clipper, right clipper and bottom clipper. So let's say you have this figure with you. So this is a window against which you have to clip the polygon, and this is a polygon. The vertices are given V1, V2 and V3. Fine. Now when we apply the left clipping, so we will draw an imaginary line from here to here. Okay, so whatever is on the left hand side out and what is on the right hand side in. So that is the rule we have to follow. Now we can follow any order to move in, but we will follow from the first vertex, that is V1. Okay, so let's see and follow those rules. V1 to V2 we are moving, V1 to V2 and both are inside. So what we have to save, that is the second vertex has to be saved. Second vertex has been saved. Okay, is it saved? So this is the follow V1 to V2. Okay, so V2 is saved. Now when we are moving from V1 to V2, now V2 to V3 we will be moving. We are moving from inside to outside, inside to outside. So what will be saved? Intersection point, that is V2 dash, and this will be clipped. So you can see, so you were having here what, v3. Okay, v3 you were having. Now you were moving from v2 to v3. Now intersection only is saved and the rest of the part will be clipped. So this is clipped. Okay, and you are left with v2 and v2 dash. Okay, v2 dash. So this is clipped. Okay, fine. Now we will move from v3 to v1. v3 is lying outside and v1 is lying inside. Okay, so when we are moving from outside to inside, then we save the intersection. We save the intersection, that is v3 dash, as well as the second vertex, that is v1. So v3 to v1 we are moving, and we have saved. If I draw a imaginary line over here, but what was the condition? v3 to v1. So we are saved with v3 dash and v1. Okay, both are saved. So we are saved with v2, v2 dash, v3 dash, and v1. Now see. Okay, so let me clear the drawings. Now see, we are left with this v1, v2, v2 dash, and v3 dash. v1, all the vertices are saved. Now these lines will be joined together, so it will be treated as a closed object. Okay, so lines across the edges are drawn. Okay, so this polygon, after left clipping, will be the input for the next clipper, that is top. Okay, now when we will apply the top clipping to this, we are saying that, okay, we are applying the top clipping to this. So see what is happening. This will be treated as outside, and this area will be treated as completely inside. Okay, this area will be treated as completely inside. So this is the area inside. So now we will start moving from v1 to v2. We are moving from v1 to v2. Both are inside. We are not concerned with the window right now. Okay, so we are concerned with about the edges across which we are clipping. So this complete region will be your inside. This complete region will be treated as inside. Okay, and this will be treated as outside. Remember. Okay, so we will start moving from one vertex to another. v1 to v2 we will move. We will be saving the second vertex. v2 is saved. Now v2 to v2 dash, all are inside. v2 dash is saved. We are moving from v2 dash to v3 dash. This is also inside because this is completely inside. So v3 dash is saved, and we will move from v3 dash to v1. So when we will come back to the first vertex, then this is also saved. So all the four vertices are saved. Okay, so the figure will remain same because all the vertices are lying inside the across this edge while performing top clipping. Okay, so fine. Now this resultant will be passed to the right clipper. Okay, and so we will apply this to the right clipping. So this is the right edge. So a line is drawn, clipping edge is drawn. So this will be treated as outside, out, and this is in. So this complete region will be treated as in, and this will be treated as out. Okay, so this you have to remember. Don't get confused with this window. Fine. So let's again follow the rule. All are inside, so all the vertices should be saved. v1 to v2 again we will move. v1 to v2 we will move. v2 is saved. v2 to v2 dash, v2 dash is saved, v2 to v3 dash, v3 dash is saved, v3 dash to v1, then v1 dash is, sorry, v1 is saved. All the vertices are saved. So basically no clipping is performed across this edge. Same is got with the, so this is the resultant figure after going across the right clipping. Now this resultant figure polygon will be passed to the next clipper, that is the bottom clipper. Okay, so bottom clipper means now you have to draw this purple line here. So it has been drawn. So this is the input to get this output. To get this output, this is the input figure. Now apply. Now apply. So we are applying the bottom. So this is out, this is in. ये in है, ये out है. Okay. Now V1 is out, V2 is in. When we are moving from out to in, then we save the intersection and we save the second point. So we are moving from V1 to V2, V1 dash will be saved and V2 will be saved, and this line will be clipped. Fine. So it is done over here. Now we will move to from V2 to V2 dash. So this is it. V2 dash will be saved. Second vertex will be saved. Okay, second vertex will be saved because both vertices are inside. Now we will move from V2 dash to V3 dash. Okay, so this line is already drawn, V2 dash to V3 dash. Now when you will do the clipping against this bottom clipping, so once again this line will be clipped and a line will be redrawn on top of this existing line basically. So when we are moving from in to out, when we are moving from V1 to V2, what is saved? That is only the intersection point is saved. Okay, so inside to outside, so it will be saved with V1 dash. So what is V2? So this is the inside vertex. So this will be treated as a intersection. What is that? Is V2 double dash. So this vertex is saved. Okay, and this part will be removed. Now you are left with V3 dash and V1. So this is the fourth case in which completely V1 and V2 are lying outside. When both vertices are lying outside, then nothing is saved. So V3 dash and V1 means nothing is saved. So this is clipped. So after clipping, you are left with this point V2 3 dash. So you can see you are saved with V1 dash. V1 dash is saved. V2 is saved. Now V2 dash is saved. Okay, and then V2 double dash is saved. Now the line will be drawn. So 2 times this part will be drawn, because in the previous clipper, this line was V2 dash to V3 dash. So this line was drawn. Okay. Now when the clipping is done, so 2 times this line will be drawn across this edge. So this is basic problem or limitation that is lying within the Sutherland Hodgman polygon clipping algorithm. But still, it is a good algorithm to clip a polygon. So this is the resultant figure after clipping the polygon across all clippers, that is left clipper, top clipper, right clipper and bottom clipper. So I think you might have understood the rules that you have to follow to clip a polygon. Let us take one more example. So first, see what are the few disadvantages related with Hodgman polygon clipping algorithm. Is first one, you are very much known with it now. it clips to each window boundary one at a time. So every boundary has to, against every boundary, the polygon has to be clipped. Then you have this method requires considerable amount of memory. The reason being, whenever we clip, you can see here, when we perform the left clipping, the edges are stored, saved. Okay, edges are stored. Now this resultant is passed to this. Then again these vertices are saved. Then the resultant is passed to this. The vertices are saved, and then again the vertices are saved. So this all eats up huge amount of, that is a wastage of memory. So just what is written over here, this method requires a considerable amount of memory. The first of all polygons are stored in original form, then clipping against left edge done and output is stored, then clipping against right edge done, then top edge, finally the bottom edge is clipped. Results of all these operations are stored in memory. So wastage of memory for storing intermediate polygons. So this is not the final result. Left clipper is not the final result. Your right clipper is not the final result, basically. So after clipping across each edge, you have to store the vertices or complete polygon. So that is the wastage of memory in storing the intermediate polygons. So, and also it has redundant edge line cross calculations, as I told you with the help of this figure, that once it is v2 dash and v3 dash, this line was generated. Now when the clipping is done, you have generated a new point, that is v2 dash. Again a v2 dash to v2 double dash, a line is generated. So 2 times this line has been drawn. One was drawn during the right clipping, another time this line is drawn during the bottom clipper. Okay, so that is the problem with this polygon clipping algorithm. Okay, let's take this example. This figure looks very huge, big, but still no problem with this. You can simply apply the rules and you can follow it. So first, very easy to go with, when we apply the left, this is out, this is completely in. When it is in, we are moving from v1 to v2. What is saved? v2 will be saved. So this will be the input vertices. We can write it like this while solving our problem. Input vertices and output. Okay, input vertices are v1 to v2 and output is v2. Likewise v2 to v3 we will move, because v2 and v3 both are inside. The output is v3. Okay, like v3 to v4 will be saved. Okay, v4 to v5 will be saved. v5 to v6 will be saved. v6 to v7 will be saved. Okay, v7 to v8 will be saved. Then v8 to v9 will be saved. Okay, now we will also move from v9 to v1, because we have started from v1. Okay, v9 to v1, so v1 will be saved. So here you can see okay, due to some network problem, the things were erased. So I hope you were able to understand how we will do the left clipping. Okay, so during the left clipper, so this will be the out, this will be N, and when we'll perform left click, all the vertices will be saved, V1, V2, V3 up to V9. Okay, all the vertices will be saved. Fine. Then we will go with the another left, then we will go with the top. Same goes with the top clipper. This is will be treated as out, this will be treated as in, and when all the vertices are lying inside, so when we'll move from V1 to V2, V2 will be saved, V2 to V3, V3 will be saved, V3 to V4, V4 will be saved. So this is done according to the rules. Okay, V4 to V5, V5 will be saved, V5 to V6, V6 will be saved, V7 to V6 to V7, V7 will be saved, V7 to V8, V8 will be saved, V8 to V9, V9 will be saved, and then we have moved to V1 and V1 will be saved. So all the vertices are saved one after another. So the polygon will remain, okay, because after storing the vertices, we draw the lines from these vertices, V1 to V2, V3, and so on. So the polygon will remain the same after top left clipping and top clipping. So this resultant figure will be passed on to the next clipper, that is right. Okay, so let me create the drawings. So this is the okay, so this is the case. Now let's move on with the rules. Okay, so this is the right clipper. In the right clipper, we will treat this part as a out, and this will be in. Now in examination, you will write about the input vertices and output. Okay, so let's say we are moving from V1 to V2, we are moving from inside to outside. So what is saved? That is, we are moving from inside to outside, the V1 dash will be saved only. Okay, so V1 dash will be saved, so this will be clipped. Fine. Now when we will move from V2 to V3, both are outside, so V2 to V3, none or none, nothing will be saved, this will be clipped. Okay, V3 to V4, so this intersection point will be required. This is out, this is in, outside and in. V3 to V4, outside, inside. So what will be saved? That will be V3 dash and V4, V3 dash and V4. So this will be clipped. Now you will move from V3 dash to V4, okay, what will be saved? Because it is inside, so V4 will be saved. And now V4 to V5, V5 will be saved, V5 to V6, V6 will be saved, V6 to V7, V7 will be saved, V7 to V8, V8 will be saved. Okay, and now V8 to V9, V8 to V9 we are moving. So when we are moving from V8 to V9, so this is inside and this is outside. So inside and outside, so this will be V8 dash. Okay, so only the inside to outside, only the intersection point is saved. Okay, and this will be clipped. Now V9 to, we will move from V9 to V1. Okay, V9 to V1 we will move, and V9 to V1 means if this is outside, this is inside, outside to inside, intersection point is saved, and the second vertex is this. Okay, so means, so V1 is also saved, so this is clipped. So we are clipped with this, so this V9 dash. Okay, so these points are calculated in such a manner. So you have got the resultant figure. This part and this intersection point and this intersection point, and rest of the part will be clipped. Okay, and let's see the figure. Okay, so this is when we have done the right clipping, when we have performed the right clipping. So this resultant figure has been done. I have shown you the rules, I have written the rules as well, and the resultant figure is this. Okay, so rest of the part is omitted and removed. Now this resultant figure will be passed on to the bottom clipper. Now bottom clipping will be applied. Okay, so let me apply it. Okay, now this will be out, this will be in. So when we are moving from V1 to V dash, let me write it very quickly now. V1 to V dash we are moving, so output is V1 dash. Now V1 dash. Now when we will move from V1 dash to, we will not move to V9, we will move to V1 dash to V3. Okay, and this intersection point will be calculated. V1 to V3 dash we will move. So when we will move from V1 to V3 dash, then this point will be calculated. So what this is in, V1 is in, and with this is out. So in and out. So this is V1 double dash. So intersection point is calculated. So this line will be clipped. Okay, so this is done. So V1 dash to V3 dash, resultant is V1 double dash. Okay, now this is V3 to V3 dash to V4 dash to V4, that is V4 will be saved. Oh, sorry, none, because both are lying outside, पूरा region के out है. So V3 dash to V4 we complete erase. Then we will move from, I'm not writing now, V4 to V5 completely out, erased. Let me write it. V3 to V4, V4 to V5, none, V5 to V6, none, V6 to V7. Okay, that is out, in. V6 dash and V7 will be saved. Okay, so this is V6 dash and V7 will be saved, and this will be erased. So you are left with this. Now V7 to V8, V7 to V8, this is in, this is out. In and out means this vertex V7 dash. Okay, this will be removed. V7 dash. Now we will move from V8 to V9. Okay, so this is out and this is in. Out to in, vertex intersection V8 dash, V8 double dash. Okay, so this is V8 double dash will be saved. Okay, so that is V8 to V9. Okay, this is okay, so this is V8 to V8 dash. So this is V8 to V8 dash, and resultant will be equal to, that is V8 double dash and V8 dash. So intersection and the second vertex all will be saved, and this will be removed. Okay, now we will move from V8 to dash to V8 V9 dash. So both are in. V9 dash will be saved. Okay, and then we will move from V9 dash to V1, and V1 will be saved. So here you can see all the points are saved, and once this will be removed, you will be able to get the resultant figure. Okay, so once it will be applied, so you will be able to get the resultant figure. Okay, so I have shown you the two examples how to work with the line of Sutherland polygon clipping, Sutherland Hodgman polygon clipping algorithm. Now I'm giving you a problem to solve in the next slide. Okay, so you have to apply the same procedures, but you have to do it very neatly and cleanly so that you should be able to understand what rules you have followed. So whenever you will apply the rule, you have to write the input vertices and the output, and here you will write the vertices, and here you will give the resultant. Okay, and after applying the left clipping, the resultant has to be drawn. Okay, then has to be passed to the top clipper, then the resultant has to be drawn, then it is to be passed to the right clipper, then the resultant has to be drawn, then the bottom clipper, then the resultant has to be drawn. So final result you will show with the help of a figure after applying the algorithm. So I hope you are able to understand what is Sutherland polygon clipping algorithm and how to implement it simply. So I leave you with this problem, and I hope you will be able to do this. Thank you all.